Okay, so last week we looked at solving graphically using a square root function, which we call a radical function. Today we're going to solve actual equations and find values either graphing or algebraically or both. Okay, so strategy for solving algebraically. List any restrictions. For the variable, you cannot take the square root of a negative number, so the value of the variable must be such that any operations under the radical sign result in a positive value. Isolate the radical and square both sides of the equation. Eliminate the radical, then solve for x. Find the roots of the equation. Okay, let's just look at an example here. All right. So I have that right there. Okay, so the first thing that they suggest you do is talk about what the restrictions are. Okay, so to talk about the restrictions, it's only based on the square root. We can't take the square root of a negative number, correct? So what I do then is I say, okay, well 12 minus x has to be greater than or equal to 0. Right? Solve for it. Therefore, x has to be less than or equal to 12. Okay? Just by adding x to the other side, I find out that x has to be less than. So there's my restriction on it. So I have to have a value that's less than 12. Now think about just in logic. If that was 13, what's 12 subtract 13? Negative 1. So there's your first value, that whole number value that's going to give us a
What if it was 12 and it would be 0?
That's okay. Square root of 0 is still 0. Yeah. Okay? So now I have to isolate the square root. So subtract 4. What's the opposite of square root?
Square.
Is the value less than 12?
Yeah.
So there's my solution for my question. Okay? Let's just keep going on examples. There is a part in here that's going to be just a little bit more difficult, but we're going to do it. We'll do it together anyways. So I've got 2 times x minus 4. Restrictions for this one?
It has to be greater than.
That's right. This has to be greater than or equal to 4. Now we're going to isolate again. So I'm going to take the 3 over. Okay? So I've got 2. Now some people would square this at this point, but I would probably divide by 2. Okay? So I'm going to get square root of x minus 4 is equal to 3 over 2. So now we're just dealing with fractions, correct? Okay, square both sides. Common denominator, right? There's your solution. Does it fit into that? Is it greater than or equal to 4? Okay. Now, calculator-wise, all right, there's 2 ways in which we can do this question. Okay. The first is to graph everything on the one side and then find an intersection point. But in this case, because it's equal to 0, I'm just going to graph y equals and find out where it crosses the x-axis. Okay? So what that means is this. To graph it, I'm going to switch that out and make that y equals. Okay? We've done this with roots, zeros, and intercepts. So that becomes y is equal to 2 x minus 4 minus 3, and then we would find out where the x-intercept is on that line. All right, so take a look at the bottom.
You do that on your graphing calculator?
Yes. This is one of the few sections. Now, what we're going to find is we're going to do a bit of work on the graphing calculator, but when it comes down to it, there's only one, maybe two questions on the actual exam that you can use the graphing calculator for. The first part of your exam is 11 questions or 12 questions in which you get the graphing calculator, but it's not to be an advantage so that somebody can't. It has to be able to do the question without it. So we will do it periodically, but our primary focus is graphing without a graphing calculator. Okay, so you will graph this. You can graph that. You don't need to do it right now because you can see the one at the bottom. Okay, so graph the function and determine the root. Now on our calculator we don't look for roots. What do we look for? Zeros. And the function has a single x-intercept at 6.25, which is that right there. Okay? You okay so far? All right. This is going to change now a little bit for this next question. So how it gets a little more difficult, it's not more difficult, it's more work, is if I have a variable on both sides of the equation. Okay? So this is where, look at example 2, sorry. So I have 3 plus okay? So what am I supposed to do here? Okay, what's the first thing I should do? It's the first thing I have to do with all these questions right now.
Restriction.
Restriction. So what's my restriction here? X has to be greater than or equal to 1. Agreed?
Yeah.
Okay. So if that's the case, then I now need to isolate my square root. So here's the catch in the whole situation. I go x minus 1 equals x subtract 3. We agree?
Mm-hmm.
All right, so watch this closely. This is where the mess up always comes in. You need to square both sides to get rid of the root. Correct?
And then you have to FOIL that side?
Yes, you do. That's right. We did this last year. You have to actually square it like that. So you can't just go x squared 9. Doesn't work like that. So now what I have, x minus 1 equals x squared minus 6x add 9. You agree? That's how it's FOILed? Okay. Yeah. Move everything to one side. And then at that point, what do we do?
Factor it?
Factor. Right? Do both of them fit into my restriction? Yeah. I also need to check the answer to make sure. So let's put a 5 in here. What's 5 subtract 1? Square root of 4.
2.
2 plus 3? 5. 5 equals 5. So that one works. 2 subtract 1.
Mm-hmm.
Square root of 1.
1.
1 plus 3 is? 4 equal 2?
No.
No. This guy doesn't work. So what I do, it's called an extraneous root. We talked about that as well. Grade 11. You cross it out. I like to use the dotted lines just so that I can see that it was a value to solve for it, but it did not work as part of my solution.
So then it's just x equals 5.
So the answer is x equals 5. But we have to show that that x equals 2 was a possible solution, but didn't work. So we X it out. Okay? It's called an extraneous root. And that whole page just kind of works you down through it. Okay, so this is all right. So far, so good. You guys following so far? So this is all the algebraic part of it. Bless you. Now, here's what's gonna happen second. I have two graphs now that I'm gonna graph on my calculator. All right, I'm gonna graph the left side. So again, you have two choices. We talked about this last year. We have two choices. I can graph just the left side and the right side and see where they intersect, or I can make it equal to 0, moving everything to one side and find out what the 0 is. Okay? So what was the equation? 3 plus square root x subtract 1?
Yeah.
That was the left side. I'm going to make that y1. Okay? And then I'm going to make y2 y equals x, the right side. Now I want you to take out your calculator and just graph those two. Please don't have your calculator.
Might not.
Where's yours?
I don't know if I
Okay, Brett, go get it. It's on the back shelf. On the back desk over there. Okay. I guess you're gonna put that in. Your window should be -10 and 1. It should work. Okay. Okay, so now you're trying, did you get it? So you got a graph. So this graph is, how does this graph move? Let's talk about what we did last week. How does the y equals square root x graph? What are the movements of that graph?
It moves to the right one on the x-axis is page.
Yeah. And then,
Vertical stretches through.
not stretch, translation. Yeah. So yeah, so it means that this goes up. So it goes from here, right? Over 1, up 3, and then I get a graph that looks like that. Agreed?
Mine
Yeah.
starts on the.
And then this guy is y equals x. So I need to find that intersection point. What is that intersection point?
Mine starts at like 3 at 1 and 0. Like it doesn't go up 3.
Okay, so let's see how you punch it in your calculator. Okay, first of all, let's shift the step on and off. You've got no add sign in there. Which you find that intersection point?
Bottom
5? Sounds right. Okay. Here's my solution. Right? X equals 5. All right. Did you get that, Brett?
Yeah.
Okay. Casey?
Yeah.
Okay. Any questions about that? So far? You want to ask? I want to. I'm going to find one of the more difficult ones here. Maybe we won't do them. We're going to get away with not doing square roots on both sides, so that's okay. All right. I don't imagine you did much over the weekend, but if you have questions from 2-1 or 2-2. You guys can just work. Okay, so we should be 2-1, 2-2. We'll finish 2-3 tomorrow. Review tomorrow. Pre-test tomorrow. Probably, does that make us Thursday, maybe Friday test? That sound about right? Yeah. Okay.
Not
So that
sure if
gives us-
basketball guys will be here on Friday.
We'll be here.
We'll be here for the first period. Okay. All right, any questions this morning? You guys just need to get back to work, basically? Okay.